rather than signing 130 individual discrete transactions across multiple environments and multiple hardware wallets, you're going to only need to sign one time, i.e. OneSig, right? Hey everyone, Brian, one of the co-founders of LayerZero, here with Robin Gauthier, our VP of Engineering. And we're going to be talking through a bunch of stuff around multi-sig, operational security, and how we think about this problem and some of the tech we've built internally that we'll be opening up sort of to the world in the coming months. So it was a real wake-up call, I think, for the entire industry. I think the industry has always been very security conscious. I think you have to be, especially when you're shipping very sensitive, immutable code, or when you're running orgs that deal with, massive amounts of money in a permissionless systems. That security is usually always top of mind. But ByBit had this huge $1.5 billion hack, and a lot of people were then acutely aware of the risks of centralized front ends, centralized back ends that are serving these up, in the way that a lot of the operational processes within many orgs are run. So we put ourselves to basically the task of running through and figuring out where exactly we can break apart these and how to deconstruct them into the most modular, sort of most secure, or really having the ability to, one of the core theses of LayerZero was always being able to own your own security. How do you give an org the ability to own independent parts of their security rather than handing it over to a third party? And how do you make sure that each of those parts individually can be compartmentalized and therefore significantly more secure as a whole? So Robin, why don't you talk us through just what does a normal multi-sig transaction look like today? What are most people doing? Set the stage.
Yeah, thank you very much. So normally what we have proposers that basically builds a payload that wants to be sent on chain, and it usually sends it to a centralized backend with a centralized front end on top of it. That's the case of Gnosis Safe. So it sends it to the backend, which basically aggregate and start bundling those different payload together, assign a nonce for replayability. Then everybody can connect to the front end and then see those payload. You usually have limited way of understanding exactly what those payload are supposed to do, because you see, Gnosis is very generic and show you the encoded payload. If you want to decode it, sometimes you've got some tools, sometimes you don't. So after that, everybody sign those payload, and then they can either rely on the front end and back end to permissionlessly execute it, or they can actually sign them themselves in order to pay for the transaction on chain themselves. So basically. Sure.
So current flow, current state of the world. And then I'm just going to talk through some of what we've been working on, and I'll use you to add technical color. So we have a proposer that basically has a series of payloads that are going to be bundled up into individual discrete transactions on some number of chains. This can be anything. This can be updating configs in a multi-sig. This can be, or in an on-chain contract. This can be changing anything in a contract, transferring funds, whatever it is. So proposer goes ahead and sets these payloads, and we allow them basically to provide any amount of human-readable metadata that they might want everybody else who's signing within the multi-sig to know. Now this, obviously, the proposer can lie about it. There's nothing necessarily security-minded than that, other than here is the intention of this thing. Please, match as you're reviewing what's actually happening to that. So that goes ahead and that gets bundled, and that gets bundled typically, again, payloads or a series of payloads into transactions with a nonce. We actually also add, or maybe we'll show that in the next diagram, but a time to deliver and expiration on that as well. So these get bundled into discrete transactions. And then you go here and you have everybody who's going to sign it. And again, as you said, historically this has always been everything gets sent to a centralized backend. Every party then views this on a centralized front end. And so one of the core things we started thinking about is what does client diversity actually look like there, and what do you add? So what this actually happens is everybody takes these payloads that they have, or these transactions that are going to be signed, and basically individually run. And these clients, we've written multiple clients internally. So these clients are written potentially in different languages with completely different backends. They're run locally by the signer. The clients have custom transformations in turning what is actually being decoded in ABI into human readable form. So again, you should be able to interpret, the signer should be able to interpret what is actually happening along with manually verifying. And each of these clients has the ability to then take this decoded ABI and take what is happening and verify that hashes to kind of what they think is should be happening and is hashed to the same as everybody else. Am I right in sort of how I'm describing that? Is there anything else that you want to add about that?
Yeah, totally. You're right. And one thing that is like when you decode an ABI on AVM, you usually just have the method signature and the name of the parent. And sometimes those one can be confusing and not very understandable. So we actually created special decoder that attach more human readable that cannot be forged by the proposer because you actually see the payload that you are about to sign. So that's an extra safeguard in case we have internally like a malicious proposer that tried to send something there. So yes.
Yep. Anything else? Talk about how, like you've talked a lot to me in private around how, again, like even just how you send this data and the fact that all of this like should basically be done over peer-to-peer networks, that you should use no centralized backends or front ends as much as possible. Like talk about the sort of depth of what you think this, what this should look like, what you think common flows will be.
Yeah, so there are definitely some of those tasks that needs to be done in a centralized way. For example, bundling and assigning the nonce needs to be done with opinion. There are multiple ways of bundling those transactions together, and so a central entity needs to do it. Now, the way that you broadcast this to other signer can be done through a peer-to-peer network instead of a centralized backend where everybody can lie about those payload and gather different signature for that thing. The client diversity is very important here, using different language between different clients, having their own human-readable decoding of those ABIs that cannot be centralized, compromised, and so on and so forth. And once everybody signed, the security is finished. Like those persons signed, you've got a threshold of signature. Anyone can permissionlessly execute on chain. That's basically.
Okay. Now let's talk about sort of what we've done with OneSig and what gets added into that entire process as a whole. So talk through a product that we've built internally, which again is not being externalized right now. All of these components will be open sourced. We've built them both for our own tooling and this thing that we call OneSig, which has a bunch of extra functionality like the ability to sign across 130 chains at a single time, the ability to sign with the same signing key across EVM and non-EVM environments, the ability to have sort of gated execution on the back end. So there's like an additional reviewer process before anything gets signed to have this additional last step check. But all of this has also been built internally for Gnosis as well. And so we will eventually open up that code as well so people can use the same process, the same tooling, and the same ability to replicate this locally in their own organizations using Gnosis Safe and using everything that they've done already. It's gone through 7 audits right now that as of today, by the time this video is released, we'll be publishing all 7 audits. So people will be seeing the audits on all of the code. We will be turning our own internal signing process over to this, to how we handle endpoints. Now, part of the LayerZero protocol itself is that the endpoint is immutable. So we're in a beneficial position in that this really just is how we update default configs, how we might deploy new endpoints, things like that. But will be much more impactful for many of the applications building on and around LayerZero and just generally across crypto as a whole, as this is applied to basically everybody running a multi-sig process, especially across many chains, but even in a single chain environment. So talk about the whole setup and kind of how we think about OneSig.
So as you already intend toward, there were 2 problems with the current single chain signing, which is something that we call internally signing fatigue. Like we want the signer to spend most of their time looking at those payload and making sure that what they are going to sign is the right thing. Unfortunately, having to use a hardware wallet, they spend a lot of time actually clicking button because it needs to produce 1 signature per chain. And we have some applications that are deployed on more than 120 chains, including the LayerZero endpoint, which make it way less performance for people, and they spend way too much time clicking button instead of actually validating that the transaction were safe and those were the right thing. So that's the first thing. And the second problem is we had to use sometimes different hardware wallet, different wallet wallet, and all the things depending on which VM we are on, because not all VM supports the same signing scheme, and that's another big problem because it does inflate the number of hardware wallets that we have, and it does create some kind of chaos regarding that. So OneSig come there and fix elegantly those two problems by basically allowing one signature to sign multiple bundles in one go. And the way that we do that is through a Merkle root. So let me just explain you the change of process. It's very, very similar to what we see and what Gnosis Safe is doing right now. The only big difference is like we can now have a proposer that send multiple payload for multiple different chain. I just put 2 chain here, but we can have like 120 chain. Then we've got, again, a bundling mechanism. We added an expiration to just give a little bit more flexibility to the proposer and to the bundler to make sure that those transactions can expire after a while. And then we create multiple bundles that are atomically sent on-chain. From those bundles, we actually treat them as a leaf of a Merkle tree, and then we create a Merkle root, and then each signer signs the Merkle root, and then from that Merkle root, the Merkle proof and the leaves, we can give that to an executor that permissionlessly execute them. And again, the beauty of that is like those signature, we use the same signature scheme across all VMs, like SVM, Aptos VM, EVM, and it is permissionless executor. There is also an optional gated execution if people want additional security internally or maybe later externally. So that process here, same as the previous diagram, can be reproduced by multiple clients. Anyone can build a client that, given those set of leaves, can Merkleize, find the same root, validate each payload within each leaf, and then finally sign the payload and then aggregate it. All the same principles that we talked before apply, where we want to have client diversity, multiple language, potentially peer-to-peer network in order to aggregate the signature. So that's basically what OneSig offer.
Sure. So just, I'm going to run through, tell me, confirm everything. So we take bunch of series of transactions across any number of chains, and just as in the former process, we bundle those into discrete transactions. Same thing, partial payloads are being split up, add a nonce, add an expiration. Expiration is what we've added. The nonce was already in the existing system, so now there's a TTL, or time to live, on all of these. You now take each of these and turn it into a leaf. You Merkleize that and construct a Merkle root. So this means that rather than signing, again, if we're deploying a new endpoint and hooking it up to a bunch of chains, rather than signing 130 individual discrete transactions across multiple environments and multiple hardware wallets, you're going to only need to sign one time, i.e. OneSig, right? Whereas normally you would have to sign for each of these individual leafs. But what you can do on the security side is you go through and you spend your time not clicking, not manually doing this, not switching wallets, reviewing each of the leaves, reviewing that the decoded ABI is actually doing what you think it's going to do. You're doing it on this local client on your own machine. You've reviewed all of them. You can confirm that the construction of these leaves Merkleizes to what you would expect it to. You compare the hash with the other signers. Obviously, you're signing the hash, the Merkle root. And then that Merkle root is aggregated. And then again, anybody can, just like in a normal Gnosis Safe transaction, execute that. Or optionally, you can add gated execution, which allows you to have an independent role separately, which will be like a reviewer. Great, all of these independent parties have signed the transaction, but now maybe you have a controller or somebody who says, okay, I'm gonna verify this, and this won't get executed unless I've said, yes, this is a valid transaction. So it just allows you to do additional gating on top of that if you want to give somebody a defining role who can't independently do anything on their own, but has the ability to always make sure that the transaction is confirmed and sort of has gone through the correct checks. And again, because of the executor side, especially in the permissionless world, executor handles gas on all of these chains, and you just have a single Merkle root, which means now you can sign on 130 chains, and you, all of the signers in the old world, all of the signers would need to have gas on every single chain. They would need to, like, it would be this mess of needing to do that, and now Nobody needs to have gas on any of the chains. Nobody needs to do anything. Everything is done through the executor, whether it's cross environment, across anything. They signed with one signing key. The role on the security side of the signers is strictly to review and verify, which allows them to focus on client tooling, on decoding, on how actually, again, the payloads are distributed to be signed, and whether that's peer-to-peer, whether that's internal front end, internal backends or not, etc. Right? Is that intent?
No, definitely. And on top of it, like simulating the payload to make sure they have the effect of what they want. Yes. In conclusion, we make it way more convenient with added security.
Yep. Okay. All right. Well, we're going to be opening, again, by the time this video is live, we will have announced OneSig itself. We'll have released all of the audits that have been done on it. Each of these individual pieces we have built for ourselves internally. This is entirely internal tooling now. Over the next series of months, we're going to work to productize this, to open up everything publicly, and just open up the tooling that hopefully does a lot to make the community and the entire ecosystem significantly safer.